everybody, welcome to another episode in Tech Zone. Today, as you see right here, we are going to discuss about data modeling in Cassandra. We have already covered one video that talks about the architecture of Cassandra, right? If you want to be having some background of that, you can watch that video and then come here. Otherwise, if you can just watch this video in isolation, that should be fine as well. So to discuss data modeling in Cassandra, there's just few concepts which you can still revisit from the previous discussion, and that is about a data center, right? So as we saw that a group of nodes like this, they form one data center, right? And then in this data center, there's something additional that we can also keep in mind is that one of these nodes is chosen at random to be the master, right? The master node. Just like you have the zookeeper, right? In HBase, you have this master node here, and then that basically governs the behavior. So this selection is done by a process called as gossip, right? So gossip is the process which chooses a node at random as a master node. And then how many nodes do you need in one data center? That decision is taken by a process called as a snitch, right? So just keep these 2 points in mind before we go into data modeling. So when it comes to data modeling in Cassandra, the thing that you have to keep in mind is that Cassandra follows a query first approach, right? So unlike your SQL, your relational databases where you first design the database schema and then you run the queries thereafter, that's not happening here. You have to first keep in mind what kind of queries do you anticipate for your requirement and then design the data accordingly, right? And in continuation to that, Cassandra follows something called as denormalization. So what is this normalization and denormalization? If you just take a simple example here, let's say in your data, you have something like this, right? Let's say uh, your customer ID, then the name of the customer, then the city of the customer, where the customer is located, then the product which the customer has bought, and then the price of the product, right? So let's say you have customer A who lives in like say city NYC, and then the product that he's bought is say a smartphone. The price is say $100,000, right? Then let's say customer B lives in LA, and then the product that he's bought is say a laptop, and then the price is say $150,000. And then again, customer A has bought something like say a desktop computer, and then the product and then the price is or let's say customer A has again bought a laptop, right? Just what customer B has bought. The price is $150, right? And then customer A lives in NYC. So here you see that customer A is repeated twice. So the name of its city has also to be repeated twice, right? It has to be pulled. And then laptop is also repeated twice. So the price of the laptop is also repeated twice here, right? So there's twice repetition here. So wherever you see the name of customer A, the city has to be updated accordingly at all those places. And wherever you see the name of the product as laptop, its value, the price has to be updated at all those occurrences where the product occurs. So this repetition needs to be done everywhere for each of the occurrences of respective values, right? So this is an example of a denormalization, which Cassandra encourages, right? Denormalization. Why does it do that? Because unlike your relational databases, what would have happened is you would have actually maintained two separate tables. One table that looks like this, which is the customers table, where you have the customer name, the city of the customer. So the name is say A and the city is say NY, and name is B and the city is LA, and name is C and city is something else. And then there's going to be a products table where you have say a product and then the price of the product, right? So say product, say smartphone is going to be costing like say $100,000, and then a laptop is going to be costing um $150,000, right? Um, okay, I meant to say not dollars, the local currency. Okay, just try to keep that in mind. Uh, right? So don't take these numbers at face value. So what's going to happen is that in SQL, it's something have something called as a join, right? In SQL. So whenever you want to produce this result, what you do is you join two tables and then you pull the respective values from there, and then you can get these results that you want, right? Using a where clause, right? So that's something which is not encouraged in Cassandra, because Cassandra wants to avoid these joins since they are time consuming, right? So it wants to promote like efficient read by promoting this denormalization, right? So this is what happens in Cassandra. So you have to keep your end result in mind and then denormalize your databases accordingly, right? So this planning needs to be done in advance, right? So if this is clear, let's come to the other concept of, say, a primary key. This is a very important concept in Cassandra. So what is the primary key? Let's say, for example, we have a data set that looks like this, where it's about the temperature measurements at different time periods, right? Different times. So and I'm using different devices. So let's say you have say device one that has measured the this temperature at times, say uh, 8 a.m. in the morning, and then 9 a.m. in the morning, and then 10 a.m. in the morning, and then the temperature value was something like say T1, T2, T3, right? Then again, you have a device two that has measured temperature at the same three times. And again, the measurement is like T1A, T2A, T3, so on and so forth, right? So here, see the device ID is going to be something in one node of the data center, right? So this node, suppose it encompasses data belonging to device one. And then within this node, you have the data for all the three times, like 1, 8 a.m., 9 a.m., and 10 a.m. And then the values like T1, T2, T3 of the temperatures, right? So if you look closely, this part of the primary key is called as the partition key. There's a concept called as partition, which decides like which node is going to include which data, right? So the partition key is the first component of the primary key, which decides like in which node is going to reside the data. So let's say this is the partition key. Let's take an example. I'm just making it up. Like device one belongs to node one, right? So this becomes a partition key. And then there's something called as clustering columns. So the time and the temperature, these become the clustering column, because this determines how the data basically resides within this node, right? So your primary key is made of these two things. Your primary key uniquely identifies your data, right? So that's composed of partition key plus clustering column. So just keep this in mind. This is the second concept that relates to data modeling in Cassandra. And then finally, we come to something which you might recall is the replication, right? So you see, you have nodes in a data center like this, and then suppose you want data from this node to be replicated across two more nodes. That is something called as a replication factor, right? So a replication factor of 2 means that data from this node is going to be replicated across two more nodes. Now, if you want to specify the replication in one data center, you have something called as a simple replication strategy, and then you have if you want to specify the replication across multiple data centers, you have something called as a network topology replication strategy. So replication strategy is the third concept here that we can keep in mind. So let's take an example. So we create a key space, right? So a key space is something where we specify how many replication nodes do we want and which replication strategy do we want, right? If you recall, that's what a key space does. So let's say we're having a key space here that talk, talks about a simple strategy. So let's say create key space ABC. So it's a query in Cassandra. Okay, now I'm writing a query. Create key space ABC. So the ABC is the name of the key space with replication with replication equals, then we have curly brackets, then we have key value pairs. We say class simple strategy, right? And then replication factor is 3. So this shows that this is a simple strategy where within a single data center, we want to create nodes where the replication factor is 3, right? That's an example of a simple strategy. And then you have something called as a network topology strategy where what you do is you can also specify the data center. So instead of having simple strategy, we say network topology strategy. We use this word over here. And then we also specify something called as DC1, 2, and then DC2, 3. So this shows you that in data center 1, you have 2 nodes replicated. The replication factor is 2. And in data center 2, the replication factor is 3, right? So this is basically much about the discussion, and this is most about the discussion on data modeling in Cassandra. There's much more to that. We can also think about queries in Cassandra. If you want further discussion on that, then please feel free to write to me. But I hope this is useful. So until then, see you in another video and keep learning. And if you have any suggestions or feedback or comments, please feel free to write in the comment box at the bottom of the video. Until then, take care. Bye-bye. If you like this video, please press the like button. For more such videos, subscribe to the channel. If you have suggestions for a new topic and would want to see a video made on that topic, please feel free to comment in the comment section below. Thanks for watching the video and see you in another video. Bye bye.